Hello everyone, welcome back to our YouTube channel Statisticians Hub. Today we will dive into the world of parametric test, more specifically Z test for proportion in IBM SPSS software for both one sample and two sample cases. So first step is to construct the hypothesis. For one sample case, null hypothesis will be H0 such that P is equal to P0. Here P is our sample proportion and P0 is the specified proportion given to us with which the sample proportion is to be compared and concluded accordingly. So to understand P, let us see this. P is equal to X by N, where X is the number of observations possessing the attribute. That is the attribute which is under consideration for this study, and N is the number of observations. Against to this null hypothesis, we have an alternative hypothesis H1 such that P not equal to P0 or P greater than P0 or less than P0. This is according to your need, whether you need one tail test or two tail test. Similarly, moving forward, we have the test statistic for single proportion, which is Z is equal to modulus of P minus P0 divided by root over of P0 into Q0 divided by N, which follows normal distribution with mean 0 and variance 1, which is the standard normal distribution. So here P we have already discussed is the proportion for our sample, P0 is the specified value, and Q0 is 1 minus P0, N is the number of observations. Similarly, construction of hypothesis for two sample, here the null hypothesis is such that H0 such that P1 equal to P2. Here P1 is the sample proportion for the first sample and P2 is the sample proportion for the second sample. Here we are going to test whether these two sample proportions are significantly different or not. Similarly, against this we have the alternative hypothesis H1 such that P1 not equal to P0 or P1 greater than P0 or less than P0. This is again according to your need, whether you need the one tail test or two tail test. So here we have the test statistic for two sample proportion, which is Z is equal to modulus of P1 minus P2 whole divided by root over of PQ into 1 by N1 plus 1 by N2. This also follows standard normal distribution with mean 0 and variance 1. Here P1 we have already discussed is the sample proportion for the first sample, P2 is the sample proportion for the second sample, P is the population proportion. That is, if we have a sample with N1 number of observation and another sample with N2 number of observation, where in the first sample we have X1 number of observation possessing the attribute, and for the second sample we have X2 number of observation possessing the attribute, then P is equal to X1 plus X2 divided by N1 plus N2. Similarly, Q is equal to 1 minus P. N1 is the total number of observation for the first sample and N2 is the total number of observation for the second sample. So now we have two examples right over here. The first problem is a certain soft drink bottler claims that less than 20% of its customers drink alcohol of another brand of soft drink on a regular basis. So a company exists which claims that 20% of its customers drink other brand of soft drink on a regular basis. Now here we have a random sample of 100 customers, yielded 18 who did in fact drink of other brand of soft drink on a regular basis. So a random sample of 100 customers are recorded, from which 18 responds such that they also drink other brand of soft drink on a regular basis. So do those sample results support the bottler's claim? Here it is given that we consider the level of significance for 0.05, that is 5% level of significance. So here 20% is our specified value, it is already given, and 18 out of 100 customers actually responded that they consume other brand of soft drink on a regular basis. So this is our one sample case for Z test for proportion. Similarly, for problem 2, we can see that in a test of reliability of products produced by two machines, machine A produced 15 defective parts in a run of 280, while machine B produced 10 defective parts in a run of 200. So, reliability of machines are compared, where machine A produced 280 products in a single production run, where 15 are defective, and for machine B, it produced 200 products in a single production run, where 10 are defective. So, we need to find the results imply, is there a difference between the reliability of two machines? And we need to consider the level of significance as 0.01, that is 1%. Now, we moved into the IBM SPSS software. Here, I have my data in the variable view. You can see that under the name, I have the first variable named brand and the second variable named number. Brand is basically the brand of the soft drink and number is the number of people consuming. The first variable brand is of type numeric because it is transformed to categorical variable. I have transformed this into categorical variable. You can see that 1 denotes local and 2 denotes other. Local means the bottler company which is claiming, and other means some other brand. And the number is of numeric type and it doesn't have any value or categorization as it is the observation. Now, if I move into the data view, here you can see that under the brand column, I have local and other, two different brands. And in total, we have 100 observation in the sample. And out of which 18 are saying that they consume other brand drinks also. So, if I put 18 in other, then 82 are remaining from the 100. So, I type 82 here. Now, first step, we go to data. We go to weight cases here. Now, we go to weight cases by and click on the number variable. Take it from the left to the right side. We click OK. You can see that in the output window, it says weight by number. We close the output window. Now we go to analyze, go to non-parametric test. Now we go to legacy dialog and go to chi-square. As IBM SPSS software doesn't have particularly Z test, so we are using chi-square test instead of Z test because Z can be transformed into chi-square or chi-square transformed into Z test or Z test statistic, as Z is equal to root over of chi-square. So now I click on brand of soft drink. I take this variable from the left to the right, brand of the soft drink, and under the values we select the values as 0.8. This is the expected values, and 0.2. Now if I click OK, we can see that an output shows brand of soft drink and test statistic, two different tables. And here under the brand of soft drink, it is nothing but the frequency. That here you can see that 82 and 18 and expected is 80 and 20. And under the test statistic, here is my statistic value, that is chi-square statistic value is 0.250 and the p value is, we can see that 0.617. Now, if we need these tables in output and draw the conclusion, we can see that the two tables are here and the noticeable part is the chi-square statistic value and the p value. And the conclusion can be drawn from this is, here the chi-square value is 0.250 with p value of 0.617, which is greater than 0.05, which indicates that the sample results supports the bottler's claim. That is, the company which is claiming less than 20% of their customers are buying or consuming other brand soft drinks is true. The corresponding value for that statistic is Z is equal to root over of 0.250, that is 0.5. Now again, for the second problem, here I have three different variables. First one is machine. That is the machines we have, machine A and machine B. Status, that is whether the product is defective or not. This is the status. And count is the observation. Everything is numeric, is of type numeric because I define this machine and status into categorical variables, as machine is a categorical variable with 1 equal to machine A and 2 equal to machine B. And here status is also 1 is defective, 2 is non-defective. So now if we go to the data view, we can see that I have my data here. Machine A defective 15 and machine A non-defective 265. Machine B defective 10, machine B non-defective 190. So similarly, we can go to we can first go to data. We go to weight cases here. We click on weight cases by. Now we click on number of items. Take this from the left to the right side and click on OK. Output window says weight by count. We close this window. Now we go to analyze. We go to descriptive statistics here. Now we go to cross-tabs. As now we need the two sample chi-square test because Z-test is not available in IBM SPSS software. So we need the two sample tests. Now we see that a new window appears. Here we take machine from the left to the right under the rows, and we take defective or non-defective or the status variable from left to the right under the columns. Now we go to statistics. We click on chi-square as I need the chi-square value. There are many other tests. We click on continue. We click OK. Now we see that in the output window, three different tables appeared. In the first table, it is nothing but the valid, missing, total. Second table, it is showing the frequency and all. Third table is our main table. Now here you can see that the chi-square statistic value is 0.030, degrees of freedom is 1, and the p-value is 0.862. We can see that in our output we have all the three tables, and in these three tables the main focus is on the p-value and the statistic value. Here we have the conclusion. The chi-square value is 0.030 with p-value of 0.862, which is greater than 0.05, which indicates that proportion of defectiveness of machine A and B does not differ significantly. With respect to that, the corresponding value of Z statistic is Z is equal to root over of 0.030, that is 0.1732, and so on. So that's all from my side. If you have any query regarding this, you can comment down. Please make sure to hit the like button and subscribe to our channel. Thank you.